Hello everyone. Through this presentation, I would like to discuss about VHDL history and VLSI design flow. VHDL stands for Very Large Scale Integrated Circuit Related Hardware Description Language. It is basically VHDL, that is Hardware Description Language HDL, and V stands for Very Large Scale Integration Circuit. So the key advantage of VHDL when we use it for system design is that it allows the behavior of the required system to be described or modeled and verified with the help of simulation before synthesis tools translate it into the real-time hardware, that is in terms of gates and wires. The another benefit that VHDL allows as a description language is it comprises of concurrent as well as sequential statements. Each statement is considered to be executed simultaneously, unlike procedural computing languages like C or other programming languages or even assembly related code languages. And the sequence of statements can run sequentially and the concurrent statements can get executed simultaneously. In general, VHDL project is a multi-purpose being created once. It can be used for many other applications many a times. Fundamentally, what we call in general is there are languages or there are systems which are reprogrammable or reusable. VHDL supports not only reprogrammable design or reusable design, but it also supports reconfigurable design that we can redefine and reconfigure. So that is the biggest advantage over the other programming platforms. Now let us go through briefly, as I mentioned already, that this is very high speed integrated circuit related hardware description language. Let us go through the history. So in 1981, first of all, it was initiated by US Department of Defense to address hardware lifecycle crisis. From 83 to 85, development of baseline language by Intermetrics, IBM and TI. Then 1986, all rights transferred to IEEE. 1987, publication of IEEE standard. It was recognized and marketed via IEEE as a IEEE product standard. 1987 is again required some comprehensive descriptions to be delivered in contest with ASICs. That was carried out. In 1984, the again standard was revised and named as VHDL. Standard is 1076 to 1993, which is out of this, most popular 1164 is used in the day-to-day application as far as software platform is considered or ISC platform is considered. In 2000, again the standard was revised from 1076 to 2000 edition. 2002, 1076 to 2002. 2007, it is VHDL procedural language application interface standard was introduced, and 2009 again revised standard name, and it is published. So these are some of the revisions which were carried out. Practically speaking, all these revisions are actually integrated, inculcated in the platforms which are provided by various service providers. Designed by IBM, Texas Instrument, and Intermetrics as a part of the DoD-funded VHSIC program, standardized by IEEE in 1987, and enhanced version of the language redefined in 1993. Additional standardized packages provide definitions of data types and expressions of timing data, that is IEEE 1164 for data types, IEEE 1076.3 that is numeric, and IEEE 1076.4 for timing. As far as reprogrammable or reconfigurable, whatever I mentioned, is considered. In general, programmable logic wise microcontroller as in prototyping. In some situations, you can design the digital system using programmable logic or microcontrollers. Programmable logic more general and flexible, economic for mass production, and microcontrollers based is more specific and less flexible, cost more in mass production. And let us have the traditional versus HDL comparison. some just briefly I would like to mention here. Procedural programming language provide how to have it, or whatever the recipe is for computation, for data manipulation, and for execution on a specific hardware model. Whereas hardware description language describes the system, it can be described from many different points, like it is behavioral, it is structural, functional properties, and as well as physical properties. In short, what it does, then what is it composed of, how do I interface to it, and how fast is it? These are the four questions or the requirements addressed by VHDL. So that is very, very important. Then usage point of view, descriptions can be at different levels of abstraction. It may be switch level, register transfer level, or instruction set architectural level. The description can be used with the help of simulation as well as synthesis. So this part we will focus on little bit in the VLSI design flow part. So design specifications are to be given, design simulation part is to be taken care, and design synthesis part for automated generation of hardware design should be carried out as a part of implement design step. In general, as far as VLSI design flow or digital system design flow is considered, so this is a general strategy. First of all, you should have the requirements. Then you have to think about what exact functionality we want to provide. Then that is a behavioral simulation part. Then there is a register transfer level design where RTL simulation and validation is done. Then there is a logic design, so logic simulation and verification. At the same time, fault simulation can be carried out. If something based on test bench, you can identify if something is to be changed or something is to be tested and then modified. So all that care as a part of fault simulation can be taken care. Once everything is done at simulation stage, RTL and the basic simulation, that is verification of truth table or whatever state table, whatever you have, then you can go for circuit design, and at that time little more focus will be given on timing simulation and circuit analysis. And lastly, the physical design, where the focus will be on a design rule checking. So this is the first general description as far as design flow is considered. From VHDL point of view, first of all, VHDL model is created at functional design step. Then VHDL model at RTL level. Here for logic simulation, we can use any inbuilt simulator or a simulator like a model sim. And then for synthesis purpose, implement design part from ISE software we can use. And from that, place and route and timing extraction can be carried out. Automation of design refinement steps, feedback for accurate simulation we can get at this particular stage once we generate the synthesis report. Next part is hardware description language as far as consider, then its role is to provide all the three basic categories from description point of view or design point of view. One is called behavioral modeling, second one is structural modeling, and third one is physical modeling. In case of behavioral, it is algorithm based, register transfer based, Boolean expression based, or transfer function based. In case of structural, it is processor, register, gates, and transistors we are actually using. And as far as physical is considered, at actual manufacturing in terms of chips, boards, or cells or modules, we can say. Design is structured around hierarchy of representations. So these are three styles or types of representations. HDLs can HDLs can describe distinct aspects of design at multiple levels of abstraction. We will get into details from modeling point of view in next presentation. So domains and levels of modeling as far as considered. So this is functional high level abstraction and low level abstraction. These are the two categories. So structural, functional, and geometric. These are the three levels as far as modeling is considered. Then in this context, if we go for functional, then you can have algorithms, register transfer, language based, Boolean equation, or differential equation. If you go for the structural, then the actual processor, memory, switches, you can use gates, you can use transistor, you can use the way we are doing. This is a general format as far as modeling is considered. Based on our requirement and the platform, we can go for the particular one. And then this one is related to your functional point of view, whatever you have like polygons, text, standard cells and floor plan. So this way you can arrange, and out of our interest, the way the programmer is actually expecting, accordingly there are three modeling styles like behavioral, structural and data flow from VHDL point of view. Those we will discuss in coming sessions. So here just I want to conclude that briefly we have gone through the history, what are the revisions took place as far as the development of this particular language is considered. And as a part of VLSI design flow, as a Y diagram, you have to remember that there are three categories where we can have some sort of structural, functional and physical or a geometric kind of arrangement. And based on our requirement from abstraction point of view, you can go for any one such technique or model. Thank you.